Welcome back to Earned Value Management. In this section, I'm going to talk about earned value calculations. And I've got this in two parts, so this is part one. Okay, so to start with, when we're doing earned value calculations, we start with a budget at completion. And so let's assume the budget at completion here is 300, and that can be 300 hours, $300. I'll use hours for all these examples. So it's a fairly short project, but this is just for illustrative purposes. So the budget is 300 hours, and we always assess earned value at some point in time. And what's common in schedules is to draw a dotted line down some part of the schedule, and we call that time now. So we want to know how the project's doing now. So assume the dotted line right here is time now. And we have a budgeted cost of work scheduled. So we talked about this in the first section. That comes from the plan. So if you recall, we had put this Microsoft project schedule together. We developed a work breakdown structure. We defined activities. We sequenced them. We estimated durations, and then we estimated the effort it would take to do each task, the hours. And what we ended up with was a plan that is a sequence of tasks, and the hours are time-phased. So each of these hours in the plan occur over a certain segment of time. So if I considered the beginning of the project to now, and let's say that is through the end of November, that was right here, there was a certain amount of work that was planned to be done by that point in time. So the budgeted cost of work scheduled is essentially just what's in the plan at this certain point of time now. And it comes from the plan. The budget of completion is this entire plan, the sum total of all the hours that are estimated for the entire project. So that is the project manager's total budget. This is the amount of work that should have been accomplished at this point in time. And it's the budgeted amount, how much you had planned to spend. All right, so in this case, let's say the budgeted cost of work scheduled is 100 hours, or the planned value in the new nomenclature is 100 hours. Budgeted cost of work performed is what is actually accomplished. And if you recall in the Microsoft project schedule, we had a column where we could put in percent complete. And so this is everything that is some percent complete. If it's an XY method, it is either started or finished. So this is what you've actually performed. And let's say this is also 100 hours. Now in the new nomenclature, this metric is called earned value, which I think is more intuitive. This is the amount of value that you earned on the project when you did work. And it's the budgeted value. It's not the actual value. So with these two metrics, we can see whether we're on schedule or not. Now graphically, you can see that we were scheduled to do this much work. We performed this much work. This project's on schedule. There's two metrics. Schedule variance is the budgeted cost of work performed minus the budgeted cost of work scheduled, or the earned value minus the planned value. We had planned 100 hours. We did 100 hours. The schedule variance is 0, and 0 means you're on schedule. If we had planned to do more work, if we had planned to do more work, budgeted cost of work scheduled, and we accomplished less, BCWP would be less than BCWS, and this would be a negative number. Likewise, if we had planned to do 100 hours of work and we did 110 hours of work, we'd have 110 minus 100, this would be a positive number. So a positive number indicates that you're ahead of schedule, meaning the earned value, or the P, would be out here, performance taken. A negative number means you accomplished less work, which means the performance would be here. There's also an index. It's the ratio of budgeted cost of work performed over the budgeted cost of work scheduled. So what I actually accomplished over what I had planned to accomplish. 1.0 means you're on schedule. If you perform less work than you would plan, this number would be below 1. That means you're behind schedule. If you perform more work than you were scheduled, that means you're ahead of schedule. This number is greater than 1. So actual cost of work performed. So I was scheduled to do 100 hours of work. I had performed, from an earned value perspective, 100 hours of work. And I spent 100 hours doing that work. So clearly this is an ideal situation where you're on schedule and you're within budget. So there's another metric. Cost variance is the work that you actually accomplished minus the hours you spent to get that work done. So in this case, we accomplished 100 hours of work. We spent 100 hours doing it. 100 minus 100 is 0. A cost variance of 0 means you're on budget. It means that when I accomplished this work, I did it for the budget allocated. If it took more hours to accomplish that work, then the ACWP would be greater than 100. The work you accomplished was 100, and this would be a negative number. So if it took you more hours to accomplish that work than you had planned, you'd be over budget. Likewise, if it took less hours to accomplish this work than had been planned, this would be a positive number. And two, there's a ratio for this as well, cost performance index. It's the ratio of the work you performed, the earned value you took, over the actual cost you incurred. And so in this case, we spent 100 hours to do 100 hours worth of work. 100 over 100 is 1. A CPI of 1 means we're on budget. If we had spent more time to accomplish this 100 hours of work, this number would be less than 1. So it would be 100, say, over 110. A number less than 1 means that you're overrunning. You're not staying within budget. Likewise, if we accomplish this 100 hours of work for less than 100 hours, say 90 hours, this number would be greater than 1. That means you're underrunning. So this all comes from this schedule, and the budgeted cost of work scheduled is in this work column. So that's 1,000 hours in this case is the budgeted cost. I'm sorry, that's the level of effort task. Elicit requirements is a better example. 500 hours is the budget for the work scheduled to elicit requirements. So by this point in time, we were scheduled to complete 500 hours of earned value, and that's BCWS. Now, this is a little counterintuitive. A task is scheduled to complete. What earned value does is it puts this in terms of hours, or it dollarizes this if you're using dollars. So you can equate work scheduled to work planned to work performed. So here we had expected to accomplish 500 hours of work at this point in time, and that's BCWS. And that shows up in this work column. So write specs with 750 hours, validate requirements with 600 hours, but we're not scheduled to get that done, 600 hours, until later. So that doesn't show up in BCWS, budgeted cost of work scheduled. Likewise, these tasks out here, this one, 5% of it was done, but it's really allocated in the future. And in this project, this 5% was done ahead of time. Here this is partially done, so only 60% was expected to be done by time now. So if you're using an XY method, you might have taken some earned value to start this. You'll get some earned value when you finished, but you're only getting partial earned value, and the actuals of 100 hours is consistent with that. You're only partially done, you haven't taken all the earned value, and you haven't spent all the budget yet. All right, so that's budget cost of work scheduled. The actual work you accomplished, so again, in project you can put in percent complete. And if you're using an XY method, you put in the percent complete you get for the X when you start, and then you make it 100% when you actually finish with the entire task. But this actual work column is the planned work times this percentage, times that percentage. So this is 500 hours times 100% equals 500 hours. Here, 450 hours times 20% is 90 hours. So in the schedule, we had only planned to take 90 hours of earned value at this point in time, at time now. So this is the budgeted cost of work performed, because we don't fill out this percent complete until we actually perform the work, and this is a percentage of the plan, the P. So here we're 100% complete, and we had taken 500 hours of earned value. So this is the earned value column, or the budgeted cost of work performed. Then the actual costs show up in this column. So this is a great example here for elicit requirements. We'd planned to complete 500 hours at this point in time. We're 100% complete, so we've taken credit, earned value for 500 hours. But we spent 600 hours to get that task done. So this is a case where this actuals, and it's kind of hard to see because this schedule is covering it, but the actuals would have been a little bit higher than the earned value you took, and a little bit higher than the schedule you had planned. Likewise here, we planned to accomplish 750 hours by this point in time. We accomplished that task, so we got 750 hours of earned value, but we spent 800 hours to accomplish that task. Here is a horrible example where we had planned to accomplish 450 hours. We've done 20%. There was only 90 hours in the plan, but we spent 800 hours to do this electrical analysis. So this is way over budget. So you can start to see the value of this. We can compare the work we should have accomplished in terms of hours at a certain point in time. We can look at the actual work we accomplished and how much it costs to do that work. And that's where these three metrics come from. Okay, so tracking progress is great. Earned value does that. Earned value also looks forward. How well have I done to this point in time? And how well do I think I'm going to do at the end of the project? Because that's really, as managers, what we want to know is, are we going to stay within this budget? So as you can imagine, this project's going pretty well. The work that was scheduled got performed, and it got accomplished within the budget. So at every reporting period, and maybe even sometimes in between, we'll do an estimate to complete. That is, how much is it going to cost? How much budget do I need to finish the project? Well, in this case, we've spent this much, this many hours, 100 hours. The estimate complete is merely the total budget minus what we spent. So the total budget is 300 hours. We spent 100 hours. 300 minus 100, we've got 200 hours left in the budget. So we've got 200 hours of work scheduled from a BCWS perspective, budgeted cost of work scheduled. We've got 200 hours of performance left, budgeted cost of work performed. And we've got 200 hours of budget remaining. So life is pretty good on this project. The estimate to complete is our current estimate of the total cost of the project. And it, quite simply, is the actual cost plus the estimate to complete. So the way you compute estimate at complete is you take estimate to complete and you add it to your actual cost of work performed. So in this case, we've spent 100 hours. We estimate we need another 200 hours to finish. 100 plus 200 is 300, and that equals the budget at completion. So the prediction on this project is that we're going to come in on budget. The variance at complete is the difference between budget at complete and estimate at complete, and in this case, it's 300 compared to 300. The variance is 0. So if the variance at complete is zero, it means we're predicting we're going to stay on budget. So there's a cost performance index. There's also a forward-looking index to complete cost performance index. And I put BAC in here. I'll show you some other ways to derive this, but this is based on the BAC. So let me talk about this equation. This is the ratio of the budgeted completion minus the budgeted cost of work performed. So remember, BCWP is the earned value that's been taken. That's the budgeted cost of the work that was accomplished. BAC is the total budget. And if I take the difference between these two, I get 200. That says there's 200 hours of performance left on the project. The denominator is the budget at completion minus the actual cost of work performed. So that's how much money I have left in the project, or how many hours I have left in the project. So we spent 100 hours doing this work. We have 300 hours in the budget. We've got 200 hours left. So there's 200 hours of performance divided by 200 hours of budget left, and the ratio is 1.0. So what this says is, I've got 200 hours in this budget. I've got 200 hours of performance left to accomplish. The project manager needs to accomplish a cost performance index of 1.0 in order to come in on budget. Well, this project manager has been accomplishing 1.0 because their performance divided by their actuals is 1. And so if this person keeps doing this, they'll come in on budget. So this is a forward-looking metric that tells the project manager what they need to accomplish in order to come in on budget. Okay, so this is an ideal case. Let's look at something different. All right, so again, we have our budget. We've got time now. We've got budgeted cost of work scheduled. Now you notice in these examples, this budgeted cost of work schedule always comes out here. The plan is the plan is the plan. You can change a plan. You've got to be very careful about doing that. If you find that the plan is so out of date that it's just not useful to compare what you actually perform and what you actually spend to the plan, you'll replan. But what most managers like to do is plan the plan and then baseline it. Don't change it. If you're changing it constantly, then you're comparing against something that's constantly changing, and that's not of much use. If you never change it and the plan is no longer representative of what you're doing, that's not very useful. But let's just assume that we never change the plan. So this BCWS is always going to show up this way. It's never going to change. It's the other metrics that vary. So budgeted cost of work scheduled is 100 hours, or plan value is 100 hours. Now in this case, we didn't perform all the work we were scheduled to do. So the budgeted cost of work performed is 90. We were scheduled to do 100. We only did 90 hours of work. So the schedule variance is going to be the work performed minus the work scheduled, 90 minus 100 minus 10. We're behind schedule. And the index is going to be the work performed divided by the work scheduled, 90 divided by 100, 0.9. Also indicates we're behind schedule. The actual cost of work performed is also 90. So we performed 90 hours of work, and we spent 90 hours to accomplish that work. So from a cost perspective, ignore that for a minute. From a cost perspective, we performed 90 hours of work, we spent 90 hours doing it, the cost variance is 0. Likewise, the cost performance index, we performed 90 hours of work, it cost us 90 hours to do it, is 1.0. So this is a really good example here. If all you were looking at is expenditures, you might think, hey, I'm doing great. I had planned to spend this much money, 100 hours. I only spent 90 hours. I'm underrunning. But earned value forces you to consider how much work did you actually do. Well, you only performed 90 hours of work. So you're not underrunning, you're behind schedule. So you ask the question, are we underrunning? Well, I did 90 hours worth of work and I spent 90 hours doing it. No, I'm right on budget. So this is the value of the earned value technique, is we're not underrunning, we're right on budget, and we're behind schedule. So let's compute the estimate to complete. The estimate to complete is the budget completion, the entire budget, minus what was actually spent. So 300 hours minus 90 hours. The estimate to complete is 210 hours. That's how many hours we have left. And the estimate at completion is the actual cost of work performed plus the estimate to complete, 90 hours plus 210, 300 hours. So despite the fact that we're behind schedule, and because we performed 90 hours of work in 90 hours, we've got 210 hours left in the budget, and we've got 210 hours of work to be performed. So here the variance is 0, because 300 equals 300. 300 hours of EAC equals 300 hours of BAC. And this method, this formula, is what we've been using to compute ETC. Now, there's a couple other methods that I'll describe to you, but this is the simplest one. When you merely take your budget, you subtract your actuals, and you say, you've spent 90, you've got 210 left. That's your estimate to complete. And again, the to complete cost performance index takes the budget at completion, subtracts the work you performed. So here too, you've got a budget of 300, you performed 90 hours of work, you've got 210 hours of performance left to do on the project. Likewise, you've got a budget of 300, you spent 90, 300 minus 90, you've got 210 hours of budget left. So your hours of performance you need to do divided by the budget you've got to do it is 1.0. So this project manager needs to keep performing at a cost performance index of 1.0 to come in on budget. Now that says nothing about the schedule. This is all about cost. And I'll talk later about techniques to get back on schedule. Maybe that's okay. Maybe in this case, schedule is not the most important thing. Maybe budget is the most important thing. If that's the case, you want the project manager to keep doing what they're doing. And they may deliver late, but they'll deliver on cost and within budget. Okay, another example. All right, here the BAC is still 300. I don't know why that's not showing up, but just remember that that's 300. Budget cost of work schedule is always the same. It's always 100. So the planned value at this point in time is 100. Now in this case, this project manager performed 110 hours of work. They were scheduled to do 100 hours of work. They performed 110 hours of work. They took 110 hours of earned value. They're ahead of schedule. And the schedule variance will reflect that. The budget cost of work performed is 110 hours. Budget cost of work scheduled is 100. It's a positive 10 schedule variance. That indicates the project is ahead of schedule. Likewise, the schedule performance index, the budgeted cost of work performed divided by the budgeted cost of work scheduled, is 110 over 100. The schedule performance index is now 1.1. That indicates the project's ahead of schedule. Here, the actual cost of work performed is 100 hours. So the cost variance is the budgeted cost of work performed, the earned value taken, minus the hours, the actual hours spent to accomplish that work. It's 110 minus 110, 0. So again, this person's ahead of schedule, and this person actually spent more money than was scheduled in the plan, but because more work was accomplished, the cost variance is 0. Likewise, the cost performance index is the budgeted cost of work performed divided by the actual cost of work performed. 110 divided by 110 is 1.0. So this too is part of the value of the earned value technique. If all you looked at was expenditures versus your plan, if you looked at the actual cost of work performed compared to the budgeted cost of work scheduled, you would say to the project manager, you were only budgeted 100 hours by this time period, but you spent 110. You're overrun. That's the wrong message. That's the wrong conclusion. The earned value method has you look at the actual work performed. So yeah, if you're ahead of schedule, you very likely are going to be overrunning and running a little bit hot. Now, maybe that's a problem. Maybe there was only 100 hours available in this period. But if the funding is somewhat flexible, you want this person to stay ahead of schedule. They're staying ahead of schedule and they're getting the work done for the budgeted amount. So if you've got the 110 hours to pay people, this is actually a good thing. And the earned value metrics show you that you're not overrunning, you're actually on track and ahead of schedule. So the estimate to complete, if you recall, is the budgeted completion minus the actual hours spent, the ACWP. It's 300 minus 110 hours. The estimate to complete for this project is 190 hours. And likewise, the estimate at completion is the actual cost of work performed, 110 hours, plus the estimate to complete, 190. 110 plus 190 is 300. So despite the fact that the ETC is lower than the previous example, the EAC is still equal to the budgeted completion. So the variance is the BAC minus the EAC. 300 minus 300 is 0. And that's because you spent more money. So the ETC is lower, but the actuals are higher, and it equals out. So the variance is 0. And again, the method we're using to compute ETC here is the budgeted completion minus actual cost. The forward-looking to complete cost performance index is the budgeted completion minus the budgeted cost of work performed. So it's this area here. There's 300 hours in the budget. There was 110 hours of work performed. So there's 190 hours of performance left in the project. In the denominator, the budgeted completion is 300 hours. The actual cost of work performed was 110. So 300 minus 110, there's 190 hours left in the budget. This project manager has 190 hours of performance left, 190 hours left in the budget. The to complete cost performance index is 1.0. So if this project manager maintains a cost performance index of 1.0 throughout the end of the project, they will finish on budget. And that's what the project manager has to do to finish on budget, maintain this cost performance index. Okay, let's do another example. Here again, we've got a budgeted completion of 300 hours. It's time now. The budgeted cost of work scheduled is 100 hours. Again, the budgeted cost of work scheduled is always 100 hours. This is in the plan, the work we need to accomplish now. In this case, the budgeted cost of work performed is also 100 hours. So from a schedule perspective, the schedule variance is 100 hours of budgeted cost of work performed, 100 hours of earned value taken, minus 100 hours of work in the plan, the budgeted cost of work schedule. 100 minus 100 is 0, a schedule variance of 0, which means we're on schedule. Likewise, the schedule performance index, there was 100 hours of work performed, divided by 100 hours of work scheduled, and that should be a 1.0. Sorry for that mistake. But the schedule performance index is 1.0, which means the project's on schedule. In this case, the actual cost of work performed is 90 hours. So the project took credit for performing 100 hours of work, but only spent 90 hours to do that work. So you can see graphically, the project is underrunning. Less money was spent to perform that work. So that'll show up in the cost variance. The budgeted cost of work performed was 100 hours. There was 100 hours of earned value taken, minus the actual cost of work performed. 90 hours spent to do that work is 10 hours. That's an underrun. Likewise, the cost performance index, the budgeted cost of work performed, the earned value taken was 100 hours, divided by the actual cost of work performed, 90 hours spent to do that work, is 1.11. So cost performance index greater than 1 means that the project is underrunning. The estimate to complete, so we're going to use this simple formula, is the budgeted completion minus the actual cost of work performed. So that's how much budget the project has remaining. The budgeted completion is 300 hours. The actual cost of work performed is 90 hours. The estimate to complete is 210 hours. And likewise, the EAC is the actual cost of work performed, how much money was spent on the project, plus the estimate to complete. That's 90 hours plus 210 hours is 300 hours. The variance of completion, because the budgeted completion, the BAC equals the EAC, the variance of completion is 0. So the forward-looking to complete cost performance index looks at the budgeted completion minus the budgeted cost of work performed. So the budget minus the earned value taken. The budget is 300. The earned value taken is 100. So 300 minus 100, this indicates there's 200 hours of performance in the plan yet to be done on the project. So that's this portion right here. In the denominator, however, the budgeted completion is 300 hours. The actual cost of work performed was only 90. So there's, like our ETC said, there's 210 hours remaining in the budget. At the same time, there's only 200 hours of performance left in the plan. So 200 hours of performance remaining divided by 210 hours of budget remaining is 0.95. So this project manager has been underrunning, performing at a cost performance index of 1.11. Because now there's more budget remaining than there is performance, the project manager could actually underperform and still come in on budget. So if for the remainder of this period the CPI were to drop to 0.95, the cost performance index were to drop to 0.95, the project manager would still come in on budget. So this is a pretty good scenario where you've got a cost performance index greater than 1, a to complete less than 1. It means that the project manager has underrun and is likely going to maintain an underrun. So let's look at this differently. What if we were to compute the ETC based on the earned value taken, the work performed? So in this case, the ETC would equal the budgeted completion minus the work performed. So despite the fact that there's 210 hours left in the budget, there's only 200 hours left of performance remaining in the plan. So let's compute the ETC that way and take the 300 hours of budget minus the 100 hours of performance. And then to compute the EAC, we'd add that ETC to the actuals. So now the estimate of completion is the money that was spent plus the estimate to complete, which was based on the difference between the budget and the performance. That's 90 hours of money of actual spent plus 200 hours in the ETC. Now the estimate at completion is 290 hours. So essentially, we're taking credit for this underrun. And in this ETC, we're taking credit for it now. Now the variance at completion is the difference between the budget at completion and the estimate at completion. We've got 300 hours budgeted, but our new estimate is 290 hours. We have a positive variance at completion. So this estimate indicates that the project is going to finish with an underrun. Now, let's compute TCPI, the to complete cost performance index, in a different way. And you'll notice these little subscripts. This is a BAC-based TCPI. This is an EAC-based TCPI. So if I do the TCPI based on EAC, I would take the budgeted completion minus the budgeted cost of work performed. So I've got 300 hours in the budget, but I've performed 100 hours. And so that numerator is just computing this area here. 300 hours minus 100 hours of work performed is 200 hours of work left to perform on the project. Now in the denominator, instead of taking the budget minus the actuals, I take the estimate of complete minus the actuals. So now my new AAC is 290. And I've spent 90 hours of actuals. 290 minus the 90 hours I've spent is also 200. So in this case, with this new revised EAC, I've got 200 hours of work yet to perform. I've got 200 hours in the budget. This project manager needs to perform at a cost performance index of 1.0 in order to come in not on budget, but come in on budget to the new estimate of completion. So if this project manager had been performing at 1.11, if they perform at 1.0, they will meet this new EAC of 290. Now, from a business management perspective, you might want to do this. If a project manager gets ahead of schedule and you let them keep that underrun, maybe they'll need it in the future. But you might have another project, if you're a business manager, that is overrunning. So at some point in time, if you've got a project that is consistently underrunning, you might ask them to do a new estimate at completion and a new estimate to complete that revises the estimate downward, shows a variance, so that that can offset something else that's overrunning. Okay, so now we have a new formula up here. A second way we can compute estimate to complete is by taking, that should be by taking budget at completion minus budgeted cost of work performed. So in the first method, we're merely just looking at how much money is left in the budget. That's the budget minus the actuals. In this second method of computing ETC, we're taking the budget and subtracting the performance, which in this case gave us a favorable variance. Okay, let's look at yet another example. Again, budgeted cost of work scheduled is always 100 units, time now, because we haven't changed the plan. Here, the budgeted cost of work performed again is 100. So we had planned to do 100, we're actually doing 100. The schedule variance is the performance minus what was in the plan, BCWS, 100 minus 100 is 0. The SPI, and this time I got it right, is the performance divided by the plan. 100 divided by 100 is 1.0. Now, the actual cost of work performed is 110 hours. So this project was less efficient. This project accomplished 100 hours of work for 110 hours. And you'll see that in the cost variance. Budgeted cost of work performed is 100. Actual cost of work performed is 110. 100 minus 110, negative 10. That's an overrun. Likewise, the cost performance index, budgeted cost of work performed divided by actual cost of work performed, is 100 divided by 110, 0.91. So this project manager is staying on schedule, excuse me, but is overrunning. Now, maybe that's what this person had to do to stay on schedule. Maybe the tasks were underestimated. Who knows why this happened? All this tells you is that we're in an overrun condition. So now the estimate's complete. If I use this first formula, is the budget minus the actuals. 300 hours of budget minus 110 hours of actuals. There's 190 hours left in the budget. And the estimate at complete are the actuals plus the estimate to complete. 110 plus 190 is 300 hours. So here the variance is 0 because we're saying the budget at complete is equal to the estimate at complete. No variance. But you probably noticed that there's this much performance left against this much budget left. So the to complete cost performance index takes the budget at complete minus the budgeted cost of work performed. 300 hours minus 100 hours of work performed. There's 200 hours of work left to perform in the plan. The denominator is the budget to complete minus the actuals. So there's 300 hours in the budget. There was 110 hours spent. There's only 190 hours left in the budget. This do complete cost performance index based on BAC is 1.05. So this project has been performing to date at a cost performance index of 0.91. But in order to finish within budget, this project has to perform better than has been done in the past. The CPI for the remainder of the project has to be 1.05 in order to come in on budget. Okay, so let's do something similar to what we did before. Let's use our second formula to compute ETC. All right, so instead of 190, we say we've got 200 hours of work yet to perform in the plan. We've only taken 100 hours of earned value of performance. Let's now assume that our ETC is 200. That's 300 hours of budget minus 100 hours of work performed, 200. Now, to recompute the EAC, we add the ETC, the estimate to complete, to the actuals. So now the EAC, all right, so this ETC should be, oh yeah, I already had that here. So the actual costs are 110 hours. The ETC is 200 hours. I take the actual cost, 110 hours, plus the ETC, 200 hours. Now my EAC is 310 hours. So now the variance, the difference between the budget at completion and the estimate at completion is 300 hours of budget minus 310 hours in my new estimate, or the project manager's new estimate. There's a minus 10-hour variance at completion. So what that says is, if you go with this new estimate at complete, the project is going to overrun by 10 hours. So now the TCPI based on EAC takes the budgeted cost, the budgeted completion, minus the budgeted cost of work performed, 300 hours in the budget minus 100 hours performed, and says there's 200 hours of performance left in the project. The estimate of completion minus the actuals is 310 hours minus the 110 hours we spent. That also is 200 hours. So this TCPI based on EAC is 1.0. So the project had been performing at 0.91, but because we increased the ETC, and because we did it based on the performance left, and because we recomputed the EAC with that, because we have an EAC of 310 hours, the do complete cost performance index based on EAC is 1.0. So if the project performs at 1.0 from here on out, they will close, they will complete within this EAC and only overrun by 10 hours. Okay, so that is still a challenge for this project. Historically, they've been performing at a CPI of 0.91. We're saying that to close on this EAC, to come within this 310-hour budget, they've got to perform at 1.0. What if we decided that 0.91 was the best this project manager could do? Well, we'd recompute the ETC yet another way. So rather than just recompute the ETC based on the performance left, we'd still compute the performance left. The budget at completion minus the 100 hours of earned value taken to performance is 200 hours. But we divide that by the current cost performance index, 0.91. So 300 minus 100 is 200, divided by 0.91 is 220. So in the first case, we revised the estimate complete upwards because we had 200 hours of performance taken. Now we've added an extra 20 hours because we don't think the project manager is going to do any better than a 0.91 cost performance index. And so we've got a larger ETC, which means we'll have a larger EAC. The EAC is the actuals plus the new estimate to complete, 220 hours. That totals now 330 hours. And the variance now goes up to negative 30. So in the previous case, we had a variance of negative 10 hours. Now the variance has gone up to negative 30. Now, if we recompute the TCPI based on this independent estimate to complete, we take the budget of completion minus the work performed, the budgeted cost of work performed. So 300 hours of earned value in the plan, in the budget, 100 hours of earned value taken, there's 200 hours of earned value left. Now in this case, we take this IEAC of 330 hours left in the new budget, the new plan. We subtract the 110 hours of actuals, which means we have 220 hours of budget remaining, which was our ETC here. 200 minus 220 is 0.91. So with this budget of 330 hours, what we're saying is if the project manager performs at the same level they have been performing, they will meet this 330-hour budget. So this may be more realistic. If 0.91 is the best the project manager can do, you surely don't want to tell them you've got to stay within the budget remaining, the original budget remaining. That required a TCPI of 1.05. You may not want to tell them, I'll give you more budget, but it's just going to be the 200 hours that were in the original plan. And you've got to stay within that because that requires a CPI of 1.0. If the best they can do is 0.91, you want to take the performance remaining divided by their historical CPI and give them essentially an extra 30 hours of budget.